Now, in this video, I'll be introducing you with the device known as transistor. And this transistor, it's a it's a three-terminal semiconductor device, and it's very much analogous to the vacuum triode. So this is why sometimes it's termed as semiconductor triode. Now, this transistor was invented by Bardeen. I think it was J. Bardeen, and Broughton and Broughton. Uh, in 1947, and they invented this transistor in Bell Telephone Laboratories. The first transistor invented by them was a point contact transistor. And here we are going to talk about this junction transistor. And what this junction transistor is, if I have to be trivial in pointing out to have the basic idea, a junction transistor consists of a thin layer. So there is a thin layer, and this thin layer is sandwiched by two opposite extrinsic semiconductors. So that can be the case. So this thin layer and it has, suppose if I say this thin layer is an N-type layer, then this has to be P-type and this has to be P-type, and we call this as PNP transistor. So in case of PNP transistor, we have a thin layer of one type of semiconductor sandwiched by the two semiconductors of the opposite type. Now, if we have the same situation, if we have a thin base of P-type material, then we will have NPN transistor. And that should be clear. So now we have symbols for these transistors, and for PNP transistor we have a symbol like this. In this case, the arrow is shown like this. Now this is the P, and this P is called emitter. And then we have this N layer which is very thin. This is called as base. And then we have another P which is called as collector. Now you can see here we have to be in a position to identify this transistor by merely looking at this arrow, because this arrow is giving us the direction of movement of the conventional current, or we should say the direction of movement of holes. Now, in the similar way, we can have a symbol for NPN transistor. In that case, the arrow will point outwards, and we will have collector, we will have base, and we will have emitter. So this will be emitter, this will be base, and this will be collector. So here we have translated the design of the the PNP design of a transistor, we can have two types of transistors, PNP transistor and NPN transistor. And how to recognize a PNP transistor is we have to seek out this symbol for that. And for NPN transistor, we have to seek out this kind of symbol. Now, talking about this emitter, this is probably, certainly it's from one side of the transistor. This is moderate in size, but heavily doped. And this heavily doped emitter, this heavily doped p-type, say for example in case of PNP transistor, this heavily doped p side is called as emitter, and it supplies the majority charge carriers for current to flow through this transistor, right? So this is my emitter. Now talking about the base. The base is here, and it's a thin layer of other type of semiconductor. If we have P here, then this is N, right? The middle region of a transistor, which is very thin and lightly doped. So here, this one is heavily doped. As I said, this P is heavily doped. This is heavily doped. And this base is lightly doped. It's lightly doped. Okay. Now the third terminal that we have, if I take this PNP transistor, this P of this transistor, this P, the other side of the transistor, which is doped slightly less than, it is doped slightly less than that of emitter, right? So doping, E-doping for emitter, say this is emitter, is greater than E-doping for collector. So, right? So what we have three types of terminals. One is emitter, then we have base, then we have collector. So this collector is slightly less doped than that of the emitter, but having this thickness slightly more than that of emitter. So the size of the collector is slightly more than that of the emitter. Getting my point? Such that this emitter size is less than that of the size of the collector, but emitter is heavily doped in comparison to the collector. Now, the junction that we can see here, if I go with this diagram, right? The junction between emitter and base. Now, this is my emitter and this is my base. The junction between emitter and base is called emitter-base junction. So I think I will redraw it in order to get a clear concept. So we have a transistor. Say I choose a PNP transistor here. Okay. Now this is my P and this is my N and this is my P. Now this junction, we call this as emitter-base junction. Right? Then we have another junction. This is between base and collector, because this is my emitter and this is my base and this is my collector. Now the junction between this base and collector, this is called base collector junction. Okay, so this is called base collector junction, or we can say collector base junction to make it symmetric. Collector base junction. Right? So this is my transistor. Now, what is the necessary condition for this transistor to be properly biased? is that this emitter base junction should always be forward biased. And we can see it exactly resembles with that of a PN junction. And we can see this whole thing made up of two PN junctions. Now, this emitter base junction, this junction that I'm talking about, this one is always forward biased. Okay? And the collector base junction, this junction, is always reverse biased. Is always reverse biased. Now, this was all about the symbolic presentation of a transistor. So if I have to go very fast, this is my PNP transistor, and this is the emitter, this is the base, and this is the collector, and this is my NPN transistor. So this is PNP and this is NPN by virtue of this arrow. So this is my emitter, this is my base, and this is my collector. So in this video we have come across the basic understanding of the symbolic presentation of a transistor, and what is a transistor, what it is made up of. In the next video, we will be discussing the working of a transistor.